We're all doing it. We download these incredibly powerful AI models from places like Hugging Face almost every day, and we just trust them. We build them into our apps, into our businesses, and they're becoming a huge part of our daily lives. But as these tools get more and more essential, a really critical question starts to pop up. What if that helpful assistant, the one that's making your life easier, actually has a hidden malicious purpose? Today, we're going to pull back the curtain on something called the AI supply chain. We're going to see how the very tools we're beginning to rely on can be turned against us. So to really get a grip on this danger, we first have to understand the battlefield. And that's the LLM supply chain. Honestly, the best way to picture it is like a food supply chain. You trust the final meal you get at a restaurant, but its safety depends on every single ingredient that went into it, from the farm to the factory to the kitchen. For an AI, those ingredients are things like its training data, its core pre-trained model, and all the code libraries that make it run. One bad ingredient can poison the whole meal.
So how exactly does this chain break? How can an attacker actually compromise your AI? Well, it turns out there are a few different ways in, but we can pretty much boil them down to three main categories.
Think of these as the attacker's main playbook. First, they can just use old-school code vulnerabilities. Yep, the same kinds of bugs that have been a problem for software for decades. Second, they can go after the AI's ingredients directly. We're talking about its data or the model itself. And third, they can actually twist the very innovations that make modern AI so powerful and turn them into weapons. Let's start with what's familiar. AI models don't just exist in a bubble. They're built on tons of software. And that software depends on other libraries and packages that can be outdated or have known security flaws. This is a classic problem, but it's just as dangerous, if not more so, in an AI context. In fact, that first big OpenAI data breach, that happened because of a vulnerability in a common Python library.
Okay, now this is where the attacks get really specific to AI. An attacker could poison the training data, secretly teaching the model to have certain biases or even creating hidden backdoors. Or they can mess with a pre-trained model directly, performing what you could call a digital lobotomy to surgically alter its behavior in some really malicious ways.
And here's the thing, innovation itself can create new risks. Right now, developers are using these amazing new techniques, like LoRa adapters. They're basically small add-ons that let you efficiently teach a big model new skills. But what if one of those add-ons is malicious? Well, it can act just like a Trojan horse that you willingly attach to your AI, creating a really subtle but powerful way for an attacker to get in.
Now, I want to be clear. This isn't just theory. This isn't some far-off what-if scenario. These vulnerabilities are being exploited right now. So let's look at a few real-world examples that show just how serious this threat has become. Take Poison GPT. This was a real attack where a malicious model was actually uploaded to Hugging Face. The attackers went in and directly messed with the model's parameters. They basically performed that digital lobotomy we just talked about. They turned it into a tool for spreading misinformation, all while getting past the platform's safety checks. Then there's the Shadow Ray attack. This one is scary because it wasn't about just one model. It was about the entire infrastructure that runs them. Attackers found holes in the Ray AI framework, a tool used by major companies to manage their AI systems, and they managed to hack thousands of servers. It just goes to show you, the risk isn't just in the model itself, but in the scaffolding that holds the whole thing up. And check out how devious this one is. Imagine an attacker takes a popular, trusted model and fine-tunes it just enough to remove its safety guardrails. But here's the trick. They specifically engineer it so it still passes all the standard safety tests. So you think you're using a safe model because it checks all the right boxes. But in reality, you're using a compromised tool that's designed from the ground up to deceive you. Okay, I know these threats are really serious, but they are not unbeatable. This is not a hopeless situation. So let's pivot from the problem to the solution. Let's open up the AI security playbook and talk about the concrete strategies we can all use to defend the AI supply chain. We can simplify our defense into 4 key pillars, 4 foundational rules. First, vet everything. You have to know where your data, your models, and your code are coming from. Second, you've got to maintain a detailed inventory of every single component. Third, test relentlessly with things like AI red teaming. And finally, fourth, patch diligently, just like you would with any other piece of software. That second point, maintaining an inventory, is so important that it deserves its own little spotlight. The tool for this is called an SBOM, which stands for Software Bill of Materials. Think of it as a detailed, signed list of every single ingredient in your AI application. It helps prevent tampering, and it means you can instantly know if a brand new vulnerability affects you. So beyond those 4 big pillars, the playbook has some other key tactics. First, always use models from verifiable sources and check their integrity with something like a signed certificate. Second, use comprehensive AI red teaming, which is basically hiring ethical hackers to find the hidden flaws before the bad guys do. Third, you absolutely need constant monitoring and observation. And finally, you have to have a plan to patch vulnerabilities the moment they're found. So after all this technical detail, why does it really matter to you? Well, it all comes down to a really fundamental idea: trust. The integrity of every single AI application, from a simple chatbot to a system controlling critical infrastructure, it rests entirely on the security of its supply chain. If that foundation is weak, everything you build on top of it is at risk. And ultimately, for AI to really reach its potential, we have to be able to trust the tools we're building with. And that leaves us with one final question to think about. As we download models, use APIs, and build the next generation of technology, we have to ask ourselves, what hidden risks are lurking in the AI tools we use every single day? And more importantly, what are we doing to find them before they find us?